Welcome to the Astro Guy podcast. I'm not an expert, I'm an amateur like you. I'm here to learn and here to teach. So let's enjoy the ride together. Carpe Noctem, seize the night. I'm your host, Wayne Zuhl, and this is the Astro Guy podcast. July continues with the naked eye planets ruling the morning skies. Mercury begins the month very low in the eastern morning sky and quickly gets lost in the twilight glow. On the 1st, at about 4:15 a.m., you can spot brilliant Venus about 6 degrees above the east-northeastern horizon. It's glowing brightly at magnitude minus 3.88, making it easy to spot if your horizon allows it. Use Venus to spot the line of bright naked eye planets in the east and south. Mars is next in line, glowing much fainter at magnitude 0.41. You can spot Mars just over 40 degrees away from Venus. It will be about 20 degrees higher and about 40 degrees south or to the right of Venus. In a telescope, Mars will appear pretty small, as it only appears a little more than 7 arcseconds wide right now. But if the seeing is good, you should be able to make out some details on the planet. Try to spot the small white southern polar cap. Jupiter is even higher and further south, about 20 degrees away from Mars. Jupiter is glowing bright at magnitude minus 2.42 and spans just over 40 arcseconds. In a telescope, you should easily be able to spot the darker equatorial bands. Keep an eye out for the Great Red Spot. Jupiter's 4 Galilean moons do a constant dance around the planet, and you'll notice the moons changing positions night after night. You can even notice that motion in an hour or even less time if you're a keen observer. Saturn is about 42 degrees to the right of Jupiter, shining at magnitude 0.55, about 35 degrees above the southern horizon. Saturn's rings are the standout feature. Try to spot Cassini's division, a gap in the rings. You'll need to crank up the magnification to spot it. The planet spans about 18 arcseconds, but with the rings, the system is about 42 arcseconds across. The moon gets in on the action around the middle of the month. On the morning of the 16th, the waning gibbous moon will be about 7 degrees away from Saturn. On the morning of the 19th, the nearly last quarter moon will be just 4 degrees away from Jupiter, while on the 21st, Mars gets in on the action as the waning crescent moon lies about 3 degrees slightly above and to the right of ruddy Mars. On the morning of the 23rd, the crescent moon will appear about 4 degrees below the Pleiades, M45, in Taurus. This should look stunning in binoculars. Just before sunrise on the morning of the 26th, you can try to spot the 27-day-old moon, which will be a very thin crescent about 4 degrees above Venus. All month long, you can spot Uranus as it appears to crawl toward Mars in the pre-dawn sky. You can spot it with binoculars as it glows at magnitude 5.87. In binoculars, it will appear star-like. You'll need a telescope to make out the disk of the planet, which only spans about 3.5 arcseconds. It will be higher in the sky as the month goes on, and by mid-month, you should be able to spot it easily before twilight begins. Neptune rises just after midnight at the start of the month, and transits the meridian after sunrise. By the end of July, Neptune rises a little after 10 p.m., and transits in the south around 4 in the morning. You'll need a telescope to spot it as it's faint at magnitude 7.7. and spans just over 2 arcseconds in size, but it is a rewarding feeling when you can find it. There's another solar system object that you can try to spot this month. Comet Pan Stars, also known as Comet C 2017 K2, was discovered in 2017 when it was more than 16 astronomical units away from the Sun, which is further away than Saturn. This comet has been pretty active as of late, and on July 14th, it makes its closest approach to the Earth as it comes within 1.8 astronomical units from us, or just less than 150 million miles away. This comet has a very large nucleus. Estimates put the size of the nucleus at between 11 and 100 miles across. Even though it's large, it doesn't get very close to Earth, and therefore it won't appear very bright. Currently, it is around magnitude 8.7 and supports a coma about 3 arc minutes in diameter. Long exposures show a tail that extends about 1/4 of a degree. For the entire month, the comet will be visible in the constellation Ophiuchus, making it an easy evening target. On the evening of its closest approach to Earth, the comet has an apparently close approach to the Globular Cluster M10 on July 14th, when the two objects will be separated by about 1/2 a degree. You can spot the comet from dark skies with binoculars, and it should be easy to spot in most telescopes. However, you'll want to try to spot the pair early in the evening, as the 97% illuminated moon will be rising shortly before 10 p.m., and by 11 p.m., its light may interfere with the fainter coma of the comet. I managed to image the comet in late June, and the large, bright coma is easy to see. The tail is relatively faint, but it is visible in longer images. Don't expect to see a tail visually, unless the comet has an outburst of activity. After its closest approach to Earth, the comet will continue to head south as it cruises toward perihelion, or its closest approach to the Sun, on December 22nd. From mid-northern latitudes, we'll be able to observe this comet until the end of August, when it dips below the southern horizon. However, observers in the southern hemisphere may get to see it for some time longer. It will be interesting to see if it has any outbursts as it nears the Sun. On July 29th, the Delta Aquariad meteor shower will be at its peak in the pre-dawn sky. However, this is a minor shower, only producing about 10 to 20 meteors per hour under excellent conditions. The good news is that the moon will only be 1 day old, and its very thin crescent won't interfere with any meteors. It's best to scan the southeastern sky about 45 degrees above the horizon to try to spot them. Moving out of the solar system, we're going to explore technically 3 different constellations this month. As night falls in the beginning of July, you can make out the house-shaped asterism of 2nd and 3rd magnitude stars that are in the constellation Ophiuchus in the southeast. Ophiuchus is known in mythology as the serpent bearer. We'll learn more about that when we explore 2 of its neighboring constellations. This constellation is interesting in many ways. It is large, more than 45 degrees tall, and easily visible from most of the world as it resides on the celestial equator. It contains several bright globular clusters that we'll explore, and much more. If you're familiar with the zodiacal constellations, you may be surprised to learn that the Sun spends more time in Ophiuchus than in the zodiacal constellation Sagittarius. You heard me right. From November 30th through December 18th, the Sun is in Ophiuchus. So if you're born between those dates and someone asks your sign, tell them that you're Ophiuchus and watch their reaction. The brightest star in Ophiuchus is 2nd magnitude Rosselhig, also known as Alpha Ophiuchi. It is easily found as the peak of the roof in the house asterism. The second brightest star in the constellation is Sabak, or Etta of Yukai, and it represents the bottom left corner of the house. Sabak has a companion, but their separation is only 0.3 arc seconds, making them virtually impossible to split with amateur equipment. If you enjoy star clusters, Ophiuchus will keep you busy. Now, we know that on the 14th of July, M10 will be joined by Comet C 2017 K2. But here's some more information about M10. It is the brightest Messier object in Ophiuchus. Glowing at magnitude 6.4, you can easily spot it with binoculars, where it will appear as a small, fuzzy glow. In a telescope, you should be able to resolve many members of this globular cluster. The cluster itself is about 85 light-years across, and it is located about 14,300 light-years away from us. To locate M10, start at Sabak and sweep about 9 degrees west-northwest to the star Zeta Ophiuchi. From Zeta Ophiuchi, sweep toward Rosselhag. After about 8 degrees, you should see the cluster in a low-power eyepiece. This globular spans about 9 arc minutes, so it's relatively compact, making it easy to spot. How many stars can you resolve? Try boosting the magnification to see if you can see more detail. A bit fainter, but just 3 degrees west-northwest of M10, lies M12, sometimes called the Gumball Cluster. This cluster is a bit fainter at magnitude 7.25 and larger than M10, spanning 16 arc minutes. You can spot M12 in binoculars as a faint patch of light. You'll want to view this through at least a 6-inch telescope, where it will appear as a mottled glow, brighter in the center and fading as you go out toward the edge of the cluster. You'll likely need an 8-inch or larger telescope to begin to resolve the individual members of the cluster, but due to its proximity in the sky to M10, it should make your observing list for July evenings. M12 spans about 75 light-years across and is about 16,400 light-years away from us. To locate our next target, sweep back to M10. Then sweep 10 degrees west and you should have M14 in your field of view. You can easily spot M14 in 50mm binoculars, where it will appear as a round patch of light, but in a telescope it's much easier to see. But its stars are faint and only resolved with larger telescopes under very dark sky conditions. M14 glows at magnitude 7.6 and spans 11 arc minutes. It is located about 30,000 light-years away from us. To locate our next target, M9, start back at Sabak and sweep 2 degrees east and then 3 degrees south, and you should have M9 in your field of view. Spanning just over 9 arc minutes and glowing dimly at magnitude 7.9, you should be able to just pick the cluster out as a small mottled glow in 50mm binoculars. In a telescope, the cluster shows up as a more concentrated glow, but you'll need a larger telescope under dark skies to resolve any members in this cluster. M9 is located about 25,800 light-years away from us. If you've got an 8-inch or larger telescope, you can try to spot 2 faint globular clusters nearby. 1 1/3 degrees northeast is NGC 6536. At magnitude 8.2 and spanning 10 arc minutes, you should be able to spot the cluster with some practice. A bit more challenging is the fainter globular cluster, NGC 6342, which is located about the same distance southeast of M9. NGC 6342 is faint at magnitude 9.6, but it's smaller, measuring less than 5 arc minutes in diameter. So if you can spot NGC 6356, you should be able to spot NGC 6342 as well. Getting back to something a little bit easier to spot, we're going to look at the globular cluster M107. To locate the cluster, start at magnitude 2.5 Zeta Ophiuchi and sweep 2.5 degrees south and then 1 degree west, and there's M107. M107 is a loose globular cluster, but with an 8-inch scope, you should be able to resolve several members of the cluster. Glowing faintly at magnitude 8, the cluster is cataloged at being 10 arc minutes across. However, The inner 3 arc minutes are best observed with amateur telescopes. M107 is about 21,000 light-years away from us. To locate our next object, look for the bright red star Antares in the constellation Scorpius, low in the south. From Antares, sweep 7 degrees east, and you'll be looking at M19. This cluster glows at magnitude 7.4 and spans 17 arc minutes. You can spot it with binoculars, but you'll need a telescope to try to resolve any of the member stars. Located about 4 degrees south of M19 is M62, known as the flickering globular cluster. M62 glows at magnitude 6.5 and spans 15 arc minutes, but the core will be easily spotted in a 6-inch or larger telescope. I've been able to view this cluster with a 70mm refractor, but a larger telescope is needed to resolve any member stars. On an interesting note, M62 is one of the most massive globular clusters in the Milky Way, and it is believed to have an intermediate black hole at its core. So, while you can see that Ophiuchus is rich in globular clusters, it has 2 constellations on either side of it that are sometimes referred to as a single constellation called Serpens. The 2 constellations represent the serpent that Ophiuchus is carrying. Serpens caput, the head of the snake, is on the western side of Ophiuchus, while Serpens cauda, the snake's tail, is on the eastern side of Ophiuchus. The constellation has several second magnitude and fainter stars, but there are 2 deep sky objects within Serpens that are 2 of the most observed and imaged objects in the night sky. We'll start with Serpens caput, as it will be higher in the sky earlier in the month. The standout cluster in Serpens caput is the globular cluster M5, which is sometimes called the rose cluster. This cluster shines at magnitude 5.6 and spans 23 arc minutes. From a very dark sky, you can just spot the cluster with the naked eye as a small, faint patch of light. It's easy to spot in binoculars, and in a telescope you should easily resolve several member stars of the cluster. The cluster spans 80 light-years and is located about 24,500 light-years away from us. To locate M5, start at Ununcale, also known as Alpha Serpentis, and sweep about 6 degrees west and then 4 degrees south, and you should see the cluster. This is easy to locate and should become an object that you'll return to over and over again. Our final deep sky object that we'll explore this month is in Serpens cauda. It is the famous Eagle Nebula, sometimes called the Star Queen Nebula, but often referred to by its catalog number, M16. The most famous picture that was taken by the Hubble Space Telescope is the Pillars of Creation. The pillars are visible with a large telescope, but there's much more to M16 than just the pillars. The entire Eagle Nebula complex spans about 1.5 degrees wide, but the brighter portions of the nebula are about half that size. To locate the Eagle, start at Sabak in Ophiuchus, and sweep just over 6 degrees east to the magnitude 3.5 star Epsilon Serpentis. Follow the line between the 2 stars for another 10 degrees, and you should easily spot the Eagle. In binoculars, you'll notice an open cluster of stars surrounded by a faint cloud. In a telescope under very dark skies, you might spot patches of dark nebula within the cloud. While in photographs, the nebula shows itself as red. Visually, it will appear grayish, unless you're using a very large, and I'm talking 1 meter plus telescope to observe it. This is an active star-forming region located about 5,700 light-years away. For some scale, the Pillars of Creation are approximately 9.5 light-years tall. Again, this is an object that you'll return to over and over again. It is beautiful in any telescope or binoculars and can provide you with hours of enjoyment exploring this wonderful emission nebula. Well, that's all for this episode. Thank you so much for tuning in, and I hope that you found our time together to be fun and helpful. If you have questions or episode suggestions, please email us at astroguypodcast@gmail.com or leave us a text or a voicemail at 973-404-0380. If you're not already a member, please join the Astro Guy Podcast group on Facebook. You'll find other members, videos, blogs, and other useful information there for your enjoyment. You can also visit our YouTube channel, the Astro Guy Podcast, for past episodes and other surprises. Please subscribe. Please consider leaving us a review on your podcast platform. It helps us to get new listeners. Thank you again for listening, and may your skies be clear. As always, Carpe Noctem. Seize the night.
I'm Wayne Zool, and this was the Astro Guy Podcast. Thank you for listening. As always, your questions, comments, and suggestions are welcome. Keep wondering. Keep your eyes on the sky. Have fun. Carpe Noctem. Seize the night.